Let's make a video showing conditional probability with the use of a tree. All right, so reading this example, a bakery employs 3 bakers who all make brownies. Aunt Jemima makes 25%, Betty Crocker 45%, and Timothy Leary makes 30%. But everyone makes mistakes. So Aunt Jemima burns 2% of her brownies, while Betty and Timothy burn 4% and 5% of theirs respectively. All right, so this is a great example of conditional probability, even though it doesn't say conditional or if given that, but it is in here. So for example, this statement right here, Aunt Jemima burns 2% of her brownies, really means that given that it's Aunt Jemima, her brownies will be burnt 2% of the time. Okay, so our first line of the tree, or the first branches of the tree, correspond to the probabilities we know, and that is who makes the brownies. So we have Aunt Jemima, so we're going to let that be event A. We have Betty Crocker, that's going to be event B, and then we have this Timothy Leary, which we're going to call event C. Okay, so there's A, there's B, and there's C. All right, so this first branch is telling us the probability. So the probability that a given brownie comes from Aunt Jemima is 0.25. The probability that the brownies come from Betty Crocker is 0.45, and the probability they come from Timothy Leary is 0.3. Okay, all that should add up to 100, which is perfect. So our next line will give us information based on going down these lines. So the brownies are either burnt or they're not burnt. So that's the second set of branches. So we'll call, we can't use B because we've already used B, so we'll say mistake. So there's a mistake given that it came from Aunt Jemima's, which is our event A, with what percent? 0.02. Okay, there's a mistake given that it came from Betty Crocker with percentage 0.04, and there's a mistake given that it came from Timothy Leary with probability 0.05. So just to be careful, these are probabilities, right? So the probability, there's a mistake given that it came down these branches. All right, so this is kind of our general form of the tree. We could find the other branches if we need them, so let's go see what the question asks. What is the probability that a certain brownie is burned? That is, what's the probability of that mistake? Well, the mistake happening, if I were to just draw a little picture of M over here of burnt brownies, we really want to partition it off into the mistakes that came from Aunt Jemima, Betty Crocker, and Timothy Leary. And sum them all up, we get all the mistakes. Well, these are, if we multiply along these lines, we have the probability of A times the probability of M given A, which we know to be the probability of M intersect A. Right? That's the definition of conditional probability. And that's that piece. If we multiply along this line, the probability of B times the probability of M given B, that gives us the probability of M and B, which is that piece. And then this last little branch that I have drawn, the probability of C times the probability of M given C should give you M and C, which is that. So if I find all of those, and those are just some calculations, so 0.25 times 0.02, this is 0.45 times 0.04, and this is 0.3 times 0.05. So if I calculate all of those and add them up, I will get the probability of M, which will give us part A. Okay, and you can verify a quick calculation that this is 0.005, this is 0.018, and this is 0.015. And adding them all up, you get 0.038. So that is our answer, 3.8%. is the probability that a certain brownie is burned. All right, so what does B say? Given that a brownie has been burned, what is the probability that it was baked by Betty Crocker? So translate this first into symbolism. So what is the probability that it was baked by Betty Crocker given that it was burned or there was a mistake? All right, that's what that says, which we know is the probability of B and M over the probability of M. Well, we can find B and M along this second traversal, which we know to be 0.018, and we just calculated the probability of M as 0.038, whatever that reduces to. Okay, so let's set up C. Given that a brownie is not burned, what is the probability it was baked by Timothy Leary? So what's the probability event C occurred given that it wasn't M? So let's be careful here. This is the probability of of C and not M over the probability of not M. Well, the probability of not N is just going to be 1 minus the probability of M. So let's come down here. If the probability of M is 0.038, then the probability of not M is 0.7. Oops, sorry. Let's fix that. Hold on. So it's 1 minus 0.038, which is 0.962. All right. Let me come over here and erase this because I'm running out of room. Okay, so that's our denominator over here. Now, what is the top, which is C and not M? Well, we have to construct one more branch down here, and that's this one. So this is the probability of not M given C. Okay, and if I multiply along this line, that is the probability of C times the probability of not M given C, which together gives you C and not M, which is what I want for the numerator up here. But what is this blue line right here? Well, it's the complement of the one above, so it should be 0.95. Okay, so what this tells us, so that's, I'm going to write it up here, C and not M, so we have 0.3 times 0.95, that gives us the C and not M, and we divide it by the 1 minus P of M, which we know to be 0.962. Whatever that simplifies to.